Basic skills 1. So starting at number 1, we have the square root of 36. So whenever we have the square root of something, right, because of this imaginary 2 that's right here, we're looking for pairs of numbers that can multiply up to whatever number is given. So we have 36. We've got to think of, well, what two numbers multiply up to 36? And to keep it simple, we are looking at 6 times 6. So once we have a pair of numbers underneath the radical is the square root sign here. Once we have a pair of numbers under that radical, we can shoot this out in front. So we'll have 6 times the square root of, and then if there were any numbers left over, once you do your factor tree here, if there's any numbers left over, you would put it in here. But for now, we have a square root of 0, which we do not need. So we're going to say our answer is 6. Now let's look at this example here. So this is outside of number 1, but it's just related to it. Let's say we want to look at the square root of 18. So square root of 18, we start by breaking this down. We got 9 times 2. 9 can break down into 3 times 3. Right? So we broke down the 18. We're not going to use that anymore. We broke down the 9. We're not going to use that anymore. So now we look at the numbers that are left. We got 3, 3, and 2. Those can't be broken down anymore. We notice that we have a pair of 3's here. That 3 comes on outside. So we have 3 times the square root, and then whatever numbers are left. And the only number that's left under there is that 2. So the 2 stays underneath. And that would be our answer in that scenario. Okay. Now let's look at number 2 here. We have negative 2 times the square root of 36. The square root of 36, we just did it in that previous problem. Right? Let's say we're someone who struggles with figuring out what two numbers multiplies up to 36, but we do notice that 36 is a even number, so we can say that is 2 times 18. 18 breaks down into 2 times 9, and then 9 breaks down into 3 times 3. And again, the numbers we break down we can't use anymore, so we're not using 36, we're not using 18, and we're not using 9. So we have a 2, a 2, a 3, a 3. Got a pair of 3's, got a pair of 2's. So now remember that those numbers come out and get multiplied to whatever's out here. So as they're coming out, we have 3 times, right, because this comes out as a singular 3. This comes out as a singular 2. So 3 times 2 times this number that was here initially to begin with, times negative 2. And then we notice anything left over, there is nothing left over, so we don't need that radical. Now multiplying this out, 3 times 2 is 6, and we still have times negative 2. And 6 times negative 2 gives us a negative 12. All right, number 3. So number 3, we have 2m times 2m squared. We're working with exponents here, right? So we have our exponent properties, and they're being applied here. Coefficients, you want to start with those first. We have 2 times 2. That gives us 4. Right? Or if you look at it in the exponent way, we have 2 to the first power times 2 to the first power. Remember when you're multiplying like bases, so we have like bases of 2. So if I do this off to the side, 2 to the first times 2 to the first, we add those. We add the exponents, so 2 to the second power, which is 4. Again, that's just a long way to do it. But it helps when we go on to these variables here. So we have m to the first power times m squared. M to the first power times m squared. Remember when blank like this one here, right? It's m to the blank power. We assume it's a 1. Okay, so now simplifying this, we have like bases. So you have to add the exponents. This would be m cubed. And that's our final answer there. Number 4, same exact concept, except this time we have 2 variables. So there's our like bases, right? X to the first times x to the first. We add those 2 exponents. That's x squared. And then we also have y to the first times y squared. Y to the first times y squared. Multiplying like bases, must add exponents. 1 plus 2 gives us 3. So that's y cubed. And again, final answer there. Number 5, we have 4n minus 6n. So 4 positive n's minus 6 negative n's. So these two can be combined because they're like terms. Right? They both have a variable of n, and they're to the same power. These are both to the power of 1. So 4n minus 6n, that would be a negative 2n. Right? And again, looking at that, we have, here's our positive n's, 1, 2, 3, 4 positive n's, and then 6 negative n's. Positive and negatives cancel each other out. Cancel, 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 cancel. There's our negative 2n. Negative n minus n. We have 2 negative n's there. Number 6, this follows the rules of PEMDAS. Right? Parentheses, exponents, multiplying, dividing, addition, subtraction. So in the parentheses first, so we look at this here, we have 1 minus x. We can't do anything with that because they're not like terms. So we move on to the next one. It is exponents. We have no exponents included. Move on to the next one. Multiplication. We do have some multiplication here because this 6 is touching the parentheses. It gets distributed to both of those terms there. So we have 7. 6 plus 6 times 1 is 6. 6 times negative x is negative 6x. And to write it in standard form, we always have to start with the variable and the highest exponent first. So the only variable we have is this negative 6x here. So we have negative 6x. We have like terms. 7 plus 6 gives us 13. There's our final answer. All right, number 7 is more of the PEMDAS. So again, start with parentheses. Nothing we can do there. Nothing we can do there. No exponents, so now we do our multiplication. 3 times m is 3m. 3 times 5 is a positive 15. Positive 2 times 2 gives us a positive 4. Positive 2 times negative 2m. Positive times a negative is a negative. 2 times 2 is 4, and then we have that m there. So now we got to look for our like terms, starting with our highest exponents first. Right, and variables, these exponents are 1. 1 happens to be the highest, so we have negative m, and then we have 15 plus 4, those are like terms, plus 19. That's our final answer there. All right, number 8. We're looking at multiplication here, and it's quite a bit of multiplication. Right? It's our FOIL method. So first we got to multiply these two here, right? The first terms. 2p times 5p. 2 times 5 is 10. P times p is going to give us p squared. Right? Remember when we do off to the side? P times p, that's to the first power, that's to the first power. Multiplying like bases, you got to add the exponents, that gives us p squared. Then we do 2p times negative 2. This is the O in FOIL, the outsides. 2p times negative 2. 2 times negative 2 is a negative 4p. Then we move on to this 5. 5 times 5 is plus 25. And that's 5 times 5p, so that's 25p. And then finally, 5 times negative 2. So positive times a negative is a negative. 5 times 2 is 10. So now we go combine our like terms. We look for our like terms. These will be combined. But when we write our answer, we need to make sure that we have it in standard form. So highest exponent first, and that's that square. So 10p squared. Negative 4p plus 25p gets combined. That's 21p, and then minus 10. All right, number 9 is one that students struggle with quite a bit. And you won't always get a positive exponent here. You will get a negative exponent. But when you state your final answer, it should always have positive exponents. So first thing you want to do, we notice this x here all by its lonesome self doesn't have an exponent. We want to put an exponent of 1 there. Right, and that helps us visualize when we have to distribute, because these are exponents raised to an exponent, which means we got to multiply these. We're multiplying all of these. So 1 times 2 would give us 2. So this is x squared. Y's exponent is 3. 3 times 2 is 6. And then x's exponent here is 3. 3 times 2 is 6. We always check to see if we can simplify further. So it looks like we have like base and a like base. Those two can be combined, right? They're being multiplied. So we can add their exponents. So this is x to the 8th, y to the 6th. And that there is our final answer. So let's say we do this, and this is outside of number 9. This is just an example. We end up with a problem where we simplified. We get x to the 6th, y to the negative 4th. What we need to do is we need to take this negative 4, right, because that negative 4 only applies to the y there. We don't want any negative exponents, so we have to drop it to the bottom. So negative tells us it's not happy being up top over here, but it will be happy when we drop it to the bottom. So the x to the 6th, that term was already positive, that stays. And because we dropped y to the bottom, now it's a happy y. So y to the positive 4th power. And again, you will run across this problem where you do have negatives and need to drop it to the bottom. And our last problem, we got to simplify the imaginary root. So what we need to do is split this up into 2. So we can split this up into square root of 9 times the square root of negative 1. Now the square root of negative 1, we learned that that is I. So we can take this off and replace this with an I. So square root of 9 times I. And when we go to write this, we want to make sure that we write it like this. I times square root of 9. Right, it's the same exact thing. This is just the standard form that it comes in. Okay, so now remember that when we started with radicals, you got to break these down. So what two numbers multiply up to 9? We get 3 times 3. And we got a pair there, so that pair comes outside. So what we're looking at, right, and it comes outside as just 1, 3. 3 times I times the square root, there's nothing left under there, so we don't need our square root. And that is our final answer there.